So what is a repository pattern? So it's one of the core ideas uh, in writing clean testable code, and that is it helps us separate domain logic from data access. So that's the most important thing theoretically, so to say. So basically what the repository pattern is, it's an object that acts like a collection of domain objects, and it's usually backed by a database, but it hides all the database details from the domain layer. Basically meaning we have our domain model, and it gives our domain model a nice clean way to load and save objects without needing to know anything about, I don't know, SQLs, ORMs, Mongo, or SOAP. So, so let's give an example here. Let's say we want to find some batches. So if we have allocate, we'll have some arguments, if I remember correctly, line and session, and then inside here, we need to do this inside the function. We need to pull the batch, and we need to write the logic for getting the session, querying on some parameters, then filtering. We don't want this, right? Why? Because it mixes business logic with database logic, and it makes tests harder because you need a database session, and it tightly couples your domain to whatever you're using, SQL Alchemy or something else. But if you have a repository, so if we had a repository, I'm just gonna jump over the unimportant stuff. So we can pull our batch from the list of repositories, and then we can call batch.allocate, and this actually keeps our domain code clean because the domain doesn't know or should care about databases. It also makes testing easier because here we can create fakes or mocks instead of real databases, and it supports domain-driven design, which is actually one of the points of this video. So this is the code of our last example in which we talked about data-driven design, but let's talk about this a bit more. So we have created a domain model here. Just for reference, a domain model is a representation of the real world business, the logic in our code. It's focused on business rules and behaviors. It's independent. It should be independent of infrastructures like databases, APIs or UI, and stuff like that. Also, we have external state. External state is something outside our pure domain logic that stores or moves data around in the real world, like databases, APIs, spreadsheets, web browsers. Think of it as having our domain model here and everything outside, like the databases or the APIs or even browsers. It's outside our pure domain logic. So the next logical step would be if we were working in an agile manner to create a web API or write tests or start plugging a web framework. So we need a way to store. Oops. We need a way to store data. We need some persistent storage. So once we create our first API, it will look something like this. So it's going to be allocate endpoint. We're going to have a line which we are pulling from the order line. Then we have batches, and then we allocate. This is just a bare bones way of writing this. This would be a lot more expanded in real life. So we need a way to retrieve a batch info from the database and instantiate our domain model objects from it. And we also need a way to save them in the database. Now, let's mention something. Our domain model should not have any dependencies, which simply means that we are keeping our core business logic, the domain model, free from any frameworks, databases, APIs, or anything similar. So it's easy to test, so it's easy to change, so it stays related to the business rules, not infrastructure noise. And for this, we are going to use something called, or we're going to implement something called the onion architecture, which is basically a way of structuring your application so that the domain model is at the center and everything else, like the database access, APIs, CLI tools, are in outer layers, and dependencies always flow inward. Let me just show you the code one more time real quickly. So we have two classes, order line and batch, and an allocation is the concept of linking an order line to a batch. And we store these allocations as collection on our batch object. All right, let me just quickly go over the code, as I said. So this entire code snippet, which has two classes, order line and batch, lives in the domain layer. It's free of dependency, is easy to test, easy to reason about, and focus purely on business rules. The first class here, the order line, is an immutable container of data. It's set to frozen equals true because it's a value object. Its identity is its data. Because it can be used in sets and dictionaries, can be mutated, and makes testing and reasoning easier. Now the class is an entity, the class batch. An entity has a unique identity, which is a reference, and it has a mutable state. It's good because it models real-life behavior. Yeah, batches are stock containers with their own life cycle. What else do we have here? We have the constructor. What can I say about this? We have these underscores. They are just saying this is internal state. Don't touch it directly from outside. We have some methods for behavior like allocate and deallocate. They modify internal state by allocating an order to the batch. We have some magic methods. These make like equal and greater than and hash. These make batch usable in sets and dictionaries, and equality is based on the reference, which is unique ID for the batch. There are some architectural benefits like proper entity modeling. And that's it. And we have a domain service, which is the allocate method right here. It coordinates behavior across multiple entities, and it returns the batch reference so the caller knows where the order went. Usually in the history, we would write our own SQL queries, but today we have tools and frameworks that are gonna generate SQL for us based on what our models look like. These frameworks are called object relational mappers because they are trying to connect the gap between the world of object and domain modeling and the world of databases. All right, let us talk about persistence ignorance. Persistent ignorance means that our domain model knows nothing about how it's stored in a database. So in other words, we have our domain classes, batch or order line or order, they should only contain business logic. They should not contain any database columns or foreign keys or anything that is tied to an ORM, which is an objectional relationship method. So we should try to avoid tight coupling to an ORM. For example, if we have a class order line, I think here is going to be a base. I'm just gonna ignore some and I'm gonna write like Q is a column, it's a string to 250 characters, and we can have something else here. So there are a couple of problems here. It's because we are tightly coupling our business objects to the ORM, because our business objects are not pure Pythoning or are now whatever ORM framework we are using. We can't reuse them outside the database context easily. And it's polluted because our domain logic now is not only thinking about what can this object do, now it's riddled with questions such as okay, primary keys, foreign keys, we need relationships, we need column types, blah 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 blah. And of course it's harder to test. So we want our domain module to be pure Python, as we had it in the code here. Like here. Domain models should be pure Python, which gives us, isolated units, clean business logic, or we can even swap ORMs later. Now, there is an alternative way. We can make sure that our ORM depends on our domain model, not the other way around. So we want, as we already have in our code, our domain model to be pure Python. So the domain model should be pure Python. And then we use whatever ORM we have, like SQL Alchemy or any alternative, and we define the table and the schema separately. And then we can map to say, okay, this database table maps to that domain class. So let's say this database table, we are going through a mapper, and this database table is mapping to this domain class. So again, we have this clean this file, which contains a clean domain model, no imports. Now we can define our table separately by creating a new file or Python, and then let me just install SQL Alchemy. I didn't have it for some reason. Done. Okay, I'm not using this terminal, so I'm not gonna even bother with it. It's already in my virtual environment. So I'm just gonna here define the table separately. So do I have SQL Alchemy now? SQL, yes, I do. Import a lot of shit from model. This is our internal model. I'm gonna import batch, and then I need metadata from here. Why can't you import it? automatically. Metadata just, it's a constructor that creates a new metadata object. So here, I'm also gonna import the table. For some reason, it doesn't import these things on its own. Oops, I'll do this. So we have batches. Just close this. Then I'm gonna have metadata. All right. And then I can create columns. I can create. Why don't you open it? Ah, I can add it. All right, good to know. ID is an integer. Can I import integer as well? I can. Oh, nice. Primary key, of course, gonna be true. Auto increment is gonna be true. And there's only one column. We can also create another one for reference, another one for SKU, for purchase quantity, and ETA. So no Python class here. We just have SQL table definition, and the table is defined in isolation from the model. And this is how we keep our ORM separate from our model and outside of the domain. I also added, I'm gonna need the date as well. I also added some other columns. Now, we also need to map the table to the domain class as well. So we have our model, we have the way data is gonna look in the database, and now we need to map these two Python files. I'm just gonna do it in the same file. From SQL Alchemy ORM import mapper. We need the mapper, and then definition start mappers mapper batch batches. And now we need to add properties. I can add all of this like this. Okay, here we have it. So what does this do? We tell SQL Alchemy this batches table maps to the batch class, and we tell SQL Alchemy how the columns map to the attributes of the domain object. And now the SQL Alchemy knows how to load and persist batch instances without those classes depending on SQL Alchemy. Once more, the repository hides the boring details of data access. It means that our domain code can pretend that all the data is just in memory, like working with a Python list or a dictionary, even if the data is actually stored in a database. This is good. This is good because we can focus on business rules, not SQL queries. We can write unit tests without setting up a database. And we can decouple our domain logic from our storage tech. So what we can create is an abstract repository. And an abstract repository, I'm also going to write it here in pseudocode. We most probably need an abstract base class as an argument with the constructor. So this method needs to be implemented by subclasses, and then we can have the method add, and then we can have not implemented here. We're gonna repeat the same for get. So we're gonna have abstract class get not implemented error. So we are defining the shape of all repositories, whether in memory or database based, which means that our domain layer and service layer will only ever call the repo.add and the repo.get. Now, here's a possible issue. Every time we introduce a new domain class like batch or order or anything else, we'll need to write a repository class for it, a way to map it to or from the database, the ORM table mapper. And this is a few lines of code. So let us also show this in code itself. We have our pure domain model here. Next, we can create repository.py, and here we're going to create the class abstract repository. What are we going to need? We're going to need to import this. Okay. The decorator just says that we need to implement, it's imperative to implement this method in our subclasses. Well, we need to import batches well from domain modeling. We can create a fake in-memory repository for test as well. So I can call it fake repository. And I'm gonna import, and I'm gonna use abstract repository as its constructor. Let me just write the rest of it. Okay,